Hello, children. Welcome to math. Let's get ready to rumble. Now, we've talked about some transformations so far. We've talked about translating, which is sliding something around. We've talked about reflecting, which is flipping something across a line. And today, we're talking about rotations. Rotations are when things go round and round. So that's what a rotation is. Now, when we talk about what an actual rotation is, what the definition of a rotation would be, we would say, well, a rotation is a transformation in which a figure is turned around a point. That point is called the center of rotation. Okay, so rotation is a transformation which a figure is turned around a point. And that point we call the center of rotation. Okay, so this is the definition of a rotation. Turning around a point, that point is called the center of rotation. Now, as it turns around, we have some different names for things. We have what's called clockwise and counterclockwise. And you can think about those as, if you had a clock, clockwise would be in the way a clock goes, to the right. Counterclockwise would be, if you have a clock, it would go time's going backwards, and counterclockwise means backwards. Okay, so that's how we know direction. Clockwise or counterclockwise is direction. We also want to know about how far to rotate, and so for that we use degrees. So we have 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So I want to draw and demonstrate what it looks like to turn at these 4 different degrees, clockwise and counterclockwise. So 90 degrees clockwise means I'm starting at the top and I'm going 1/4 turn to get right here. 180 means I'm starting at the top and I'm going halfway around to get right here. 270 means I'm starting at the top and I'm going 3/4 of the way around to get over here. And 360 means I'm doing a full loop all the way around my circle. Okay, so that's how we know how far to go. 90 degrees is 1 turn, 180 degrees is 2 turns, 270 is 3 turns, 360 is all the way around. That works similarly for counterclockwise. Counterclockwise, I start at the top. Whoa, I don't know what I just drew there. That was crazy. I start at the top and I go 1/4 turn to the left. 180 takes me 2/4 turns to the left. 270 takes me 3/4 turns to the left, and 360 takes me all the way back around again. And if we notice here, we have some things that help us end in the same location. That means that those directions are the same. 360 degrees is the same no matter what. We're both going all the way back around, ending at the very top. 180 degrees is the same, clockwise or counterclockwise. We're both going halfway around and ending up at the bottom. Now, 90 degrees clockwise ends here on the right, and 270 degrees counterclockwise ends here on the right. Those two are the same measure. We just call them different names, but they are the same measure. They end us up in the same place. And same with 90 degrees counterclockwise and 270 degrees clockwise. They both end us here on the left side. Okay, so 90 degrees clockwise is the same as 270 degrees counterclockwise. 90 degrees counterclockwise is the same as 270 degrees clockwise. So even though they have different names, they both will end up in the same place. And you can do the same thing for both of those movements. Now, let's talk about how do those movements actually look? What do those movements look like if I were to map them out? Let's say I have a point here, and here, and here, and here. And in my point, I have this N shape, and we will call this shape W, X, Y, Z. W, X, Y, and Z. Now, what I'm doing when I have a rotation is, and what's cool about doing this on my computer here is I can literally just click on this button and I can rotate my shape all the way around and around and around. But what I'm doing is I'm going to rotate 90 degrees clockwise. So I'm going to go 1 quarter or 1 quadrant turn around this way to the right. So what that would look like is if I just moved this shape all by itself, if I just said, hey, I want to move this shape all by itself, I would go, okay, well, 1 quarter turn is going to flip it on its side and put it right here. Now, that's great, but that doesn't move it to my next quadrant. I actually want it to move to my next quadrant. And the way I'm going to do that is I'm going to make sure that it is all the way down here. And I will tell you why it needs to go all the way down there in a second. Let me redraw this shape because I just took away my other one. Redraw my shape. And that is actually where this is supposed to go. And I will keep this as W prime, X prime, Y prime, and Z prime. So these points here match. W matches with W, X, Y, and Z all match together. So nice and pretty. Now, like we did with reflection, I want to think about, is there a rule that I can find that's going to help me know how to do what I just did a little bit more mathematically? Well, it's a great question to ask myself, and I would say, all right, self, let's try and solve that. So we're going to say point W, X, Y, Z. Here is my pre-image, and here is my image. Let's see how this looks here. So the coordinates for my pre-image, W is at 2, 1. X is at 2, 5. Y is at 4, 1. And Z is at 4, 5. That's my pre-image. My image, I have W at 1, -2. X is at 5, -2. Y is at 1, -4. And Z is at 5, -4. Now, if you were to look at these points, like we did yesterday, what's a rule we can make to get from my pre-image of a point XY to my image? And what point would that be? Well, if I look, my values all swapped. So if you look here, 4 and 5 swapped. 4 and 1 swapped. So I could say that I know my values are going to swap order. My Y value will come first, and my X value will come second. So I know that's swapping. And then I can say, okay, well, even on this, look at all of my old X values. What's happened to them? Well, they've all become negative. So I can say any point that I'm starting with, if I want to rotate it 90 degrees clockwise, or 270 degrees counterclockwise, this is the rule I want to follow. So we're going to go make a list of rules really quick. We're going to say rules. Say rules. And we're going to say 90 degrees clock or 270 degrees counterclock. I'm going to call that C clock. The rule for 90 degrees clock or 270 degrees counterclock is my ordered pair of x, y will become y negative x. That's my rule. It's going to go from xy to y negative x. If I were to take this shape and I were to say, all right, shape, I want to rotate you some more. I'm going to rotate you another turn clockwise. I'm going to rotate you one more time clockwise here. And this is going to be now, this is my W, X, Y, Z. Now I said, okay, well now what's my image at? Oh man, I erased that big line there. What's my point of my image at now? And this is now getting rid of my here, but I've rotated all the way around. Well, W started at 2, 1. It's now at -2, -1. X is now at -2, -5. Y is at -4, -1. And Z is at -4, -5. So my rule that I can create is to say, well, to get from preimage to image going 180 degrees, I'm going to take my X and Y value. They're going to stay in the same place this time, but I'm going to make them both negative. So if I want to say, what's my rule for a 180 degree rotation? And I don't care if it's clockwise or counterclockwise because 180 degrees gets me to the same place. Well, I would say my XY becomes -X, -Y. So both values change if I'm rotating 180 degrees. All right, I promise we are almost there. We will be done so soon. One last turn. We've done 90 degrees clockwise. We've done 180 degrees. What we need to do is 270 degrees clockwise or 90 degrees counterclockwise. Let's see what that would look like. So if I'm starting here, then I'm taking my shape and I am moving it 90 degrees the other way and bringing it on over. It would look something like this. And I would have W, X, Y, Z. Just like this. Wow, a rare triple prime. Unbelievable. I can't believe we've done this. It's the greatest day ever. All right, and I were to make these same markings, make a same rule. I would say, okay, well now W started at 2, 1. It is now at -1, 2. X is now at -5, 2. Y is now at -1, 4. And Z is now at -5, 4. And we can say, okay, well, the relationship, the rule that we've just created is our order switched, YX, and our Y value this time became negative. So we get to our rule is now xy becomes negative yx. Negative yx. So these are the three rules that we have for rotating any and all turns. 360 is going to stay exactly the same, so we don't even need a rule for that. It just stays the same. But for all the rest, this is how you go from your original point and rotate. Now, let's say I take these rules here, and I say I'm going to start with the point 4, 8. And I want to rotate 270 degrees counterclockwise. What point would I end up with? Sorry this video is so long. Thank you for being so patient with me. I will see you all tomorrow. Have a great night.